In the previous video, we looked at the graph of a quadratic equation, and we found that there are some really important points that we need to make sure we always highlight when graphing quadratic equations. So some of those points, 3 of the 4 points, in fact, were intercepts. Okay, so let's do a quick overview of intercepts. Part of this is review, part of it is understanding that it's something we've always been doing, and then a small part of it's kind of new. Okay, so first of all, intercepts. We have to go back to when we were talking about graphing linear equations in two variables. Okay, intercepts are points where a graph crosses or touches the x or y axis. That's easy enough to understand. We have a Cartesian plane. We're going to use a line here just for the sake of ease. We have some line. Well, this line has two intercepts. It has an x-intercept here and a y-intercept here. Those are points where the graph crosses the x or y axis. So that's easy enough to understand. All right. Now, a little bit more specifically, a point where a graph crosses the x-axis is very specifically called the x-intercept, and it's going to be of the form x comma 0. And hopefully that kind of makes sense. We have an x-intercept right here, okay? And in order to get to that ordered pair, if we were just plotting points, we would start at the origin. We would need to go left or right, in this case left, to get to that point, and then we don't go up or down. That means the ordered pair has some x value, but then the y coordinate is always going to be 0. So the x coordinate is going to be some non-zero number, and then the y coordinate is always going to be 0 because in order to be on the x-axis, we never go up or down, okay? Now, a point where the graph crosses the y-axis is very specifically called a y-intercept, and those points are of the form 0, y. So if we look right here, we have a y-intercept. And if we look at how we could get to that ordered pair just by plotting points, we would start at the origin. We would not go left or right, which means the x-coordinate has to be 0, and then you just go up or down until you get to the point. So all y-intercepts are going to have 0 as the x-coordinate and then some value for the y-coordinate. Okay, and that's really important because the steps to find intercepts are all going to be based on what we just talked about in that graph. So when you're trying to find x-intercepts, we let y equals 0, and then we solve for x. All right. When we're looking for y-intercepts, we let x equal 0 and then solve for y. So essentially, whichever intercept you're looking for, you let the opposite variable be 0 and then just solve for the variable you were looking at to begin with. Now, let's talk about something. Earlier in this video, or in this worksheet, we talked about the basic equation for a quadratic, and it is y equals ax squared plus bx plus c. Well, let's talk about this right here. If I wanted to find the x-intercepts, I would let y equal 0. So I would let y equal 0, and I would get ax squared plus bx plus c. Well, this format right here, you've seen this before. This is standard form. And so basically, standard form of a quadratic is set up so that you can solve the quadratic. So when we were talking about solving quadratics by factoring or the square root method or completing the square or the quadratic formula, in all of those cases, we started out by looking at standard form. And in a couple of those cases, we had to do some tweaking, but we always kind of had this idea of standard form behind the scenes. Well, standard form was set up just so we could find our x-intercepts. So all along, when solving, we were just finding x-intercepts. So finding x-intercepts, well, we were finding x-intercepts. I'm going to shorten that to INTS just for the sake of space. So all this time when we were solving or learning how to solve quadratics by factoring, the square root property, completing the square quadratic equation, when we had that idea of standard form and we were solving those, we were just finding the x-intercepts all along. So when we go to find x-intercepts to graph the equation, we're doing stuff we've already known how to do for quite some time. Okay, now to find the y-intercept, we just let x equal 0. So let's think about that. We have y equals ax squared plus bx plus c. Well, if I let x equal 0, the ax squared term becomes 0, the bx term becomes 0. 0 plus c is just c. So when we're finding y-intercepts, for quadratic equations, it ends up just being the constant, okay? So there's nothing too crazy about that. We already know how to find x-intercepts. We've been doing that all along, okay? When we've been solving these quadratics, we were secretly finding x-intercepts. Finding the y-intercept, not bad. So let's go ahead and look at example 2. So example 2 says find the x and y intercepts of each quadratic equation. Now, when you're finding x and y intercepts aren't bad. X intercepts, you have to implement one of the methods that we've learned for solving. So we know how to solve quadratics by factoring, the square root property, completing the square quadratic formula. Generally speaking, you always want to see if your quadratic is factorable because that's going to be quickest, okay? And if it's not factorable, most of the time we'll use the quadratic formula, okay? So let's look at A. We have y equals x squared minus 6x plus 5. So let's look for the x-intercepts. In order to do that, we're going to let y equal 0. So we're basically just going to put this in standard form. And I want to see if this is factorable. This is a quadratic trinomial. The coefficient on the square term is 1. So we want to see if this will factor as two binomials using that shortcut method for factoring. So that would mean we're looking for factors of 5 that have a sum of -6, okay? Well, in order to get factors of 5, both factors have to be positive or both factors have to be negative, okay? So we could try -5 and -1 or 5 and 1, and those are the only pairs of factors of 5. Do either of those pairs of factors add up to -6? Well, yeah. This pair of factors adds up perfectly. So if I take -5 times -1, I get +5. And if I take -5 plus -1, I get -6. So I would just say this is x minus 5, x minus 1. So we have factored. Now we apply the zero product principle. So I take each factor of my product and I set it equal to 0. Well, if I have x minus 5 equals 0, I just want to add 5 to both sides. Well, 5 minus 5 is 0, or -5 plus 5 is 0, leaving me with x. 0 plus 5 is 5. That means my first x-intercept is the point 5. And remember, we let y equal 0, so this is the point 5, 0. Okay? Now, for the second point, we have x minus 1 equals 0, so I want to add 1 to both sides. Well, -1 plus 1 is 0. X plus 0 is just x. And then 0 plus 1 is 1. So this ordered pair for this x-intercept is going to be x coordinate of 1, y coordinate of 0. Okay, so right here we have our x-intercepts. Now for the y-intercept, it's easy. To find a y-intercept, we let x equal 0 and we solve for y. So we get y equals, well, 0 squared minus 6 times 0 plus 5. Well, 0 squared is 0. -6 times 0 is 0. 0 minus 0 plus 5 is 5. So this ordered pair, remember, we let x equal 0 and we solved for y. So there you have your intercepts of the first quadratic. Okay? Now looking at part B, there's one part that I'm already like, ooh. So let's think about this. We know that in order to find the x-intercepts, we have to put the quadratic equation in standard form. And in several of the videos when we were talking about solving quadratics and we were asked to put things in standard form, I always said, put things in standard form in such a way that the squared term stays positive. Okay? Now looking at this quadratic equation right here, I can see that the coefficient of the squared term is -1. So that tells me a is less than 0. So this tells me this parabola opens down. This is really important, the fact that we have y equals -x squared. Okay. However, when it comes to solving or finding those x-intercepts, I'm going to tweak this. So I want to put this in standard form. But I like for the squared term to be positive. So I'm going to go ahead and add x squared to both sides. I'm going to add 2x to both sides, and I'm going to subtract 3 from both sides. So 0 plus x squared is x squared. X squared plus 2x is x squared plus 2x. X squared plus 2x minus 3 is x squared plus 2x minus 3. And then this right-hand side now becomes 0. So all I did was move all of the terms that were originally on the right to the left so that my squared term stayed positive. To me, I think it's easier to find the x-intercepts when the squared term is positive. You don't have to do this necessarily, but for me, it's easier. So now we want to see if we can solve this by factoring. So we have a quadratic trinomial. The coefficient of the squared term is 1, so that means this is potentially easy factoring. So let's see if it works out that way. We want to see if there are factors of -3. That means one factor is positive, one factor is negative, and we want those factors to add up to 2. So we could use -3 and 1 or 3 and -1. Do either of those pairs of factors add up to 2? Well, yeah, 3 and -1. So we want to come over here and say this is x plus 3, x minus 1, and that equals 0. We have a product equaling 0, so we apply the zero product principle. So I'm going to set each factor of the product individually equal to 0. And then solve them. So if I have x plus 3 is 0, I want to subtract 3 from both sides. 3 minus 3 is 0, leaving me just an x on the left. And then 0 minus 3 is -3. That tells me my first x-intercept is -3, 0. Remember, we let y equal 0. Now I have x minus 1 equals 0. I want to add 1 to both sides. -1 plus 1 is just 0, leaving me an x on the left. And then 0 plus 1 is 1 on the right. So my second x-intercept is the ordered pair 1, 0. So those are my x-intercepts, okay? And now let's look at our y-intercepts. Okay, in order to find y-intercepts, we let x equal 0, and then we solve. So we can go back to that original equation. We don't have to worry about the squared term being positive or anything. So I get y equals -0 squared minus 2 times 0 plus 3. So I get y equals, well, let's see, 0 squared is 0, -2 times 0 is 0 plus 3. So I get y equals 3. And that's the ordered pair 0, 3. So that is my y-intercept. Now, just for fun, let's take a moment and we're going to go to Desmos, okay? So let's go to Desmos here. Let me stop share. We're going to go here. But for this one, we're going to go to, remember, desmos.com. We've talked about this a few times. So Desmos. When you go to desmos.com, you want to open the graphing calculator, and let's just look at these two equations to see if our x and y intercepts match. So the first equation that we had was y equals x squared, so you can just do x and then use the little caret button, which is shift 6, and then 2. Hit the right arrow to kind of leave that exponent world, and then we want to do minus 6x plus 5. All right, there we have it. So if we look at our x-intercepts, we said our x-intercepts were 5 and 1. So this right here is an x-intercept, and it's 1, 0. This right here is our other x-intercept. It's 5, 0. And this is our y-intercept, which was 0, 5. So if you have your worksheet in front of you with all the work on it, you can see that for part A of example 2, our x and y-intercepts really do match, and you can kind of get an idea of what the graph looks like. Now, we haven't found the vertex yet, but our vertex here would be 3, -4. Okay, now the second equation that we had was y equals -x squared minus 2x plus 3. Notice for this one, we pointed out the fact that a was less than 1, or a was less than 0 rather, so a was negative, and we found that this was going to open down, and it does. You can see that this one definitely opens down. We had that our x-intercepts were -3 and 1. Well, look at that. We have an x-intercept of -3, 0 and an x-intercept of 1, 0. We also found that the y-intercept was 3. So we have a y-intercept of 3. So the point 0, 3. And we weren't asked for it yet, but the vertex really right here is the point -1, 4. So even though we weren't asked to graph these two examples, there you have a vision of what the graph is, and you can see that our x and y-intercepts are legitimate. Okay? So that's it for finding the intercepts. Again, it's mostly review. We've been finding x-intercepts all along. We just weren't saying they were x-intercepts, and then finding the y-intercept is pretty simple.